This video is going to build on the previous video we had that used a servo and a gyroscope on top of that servo to turn to a particular position. And it's going to now take that gyro and put it on top of a robot and turn the robot to that particular position. We're going to do this in two parts. The first part is going to be to have the robot always point the same direction. So just like with the servo, if it's positive or negative, we'll be doing something. If it's 0 or close to 0, we're going to just sit there. So we're not going to be using servo, so we'll take that away. But we'll be using our motors. These servos, servo position, you can delete that. Then you can also go down and delete all the stuff that has to do with the servo. So servo position plus plus, servo position minus minus. We'll delete those. We'll delete the servo position, the telemetry data. And we'll just delete this part here in the conditional statement. Oops, one too far. And then we're going to add in some motors. And for the second part, we're going to need the motors to be public inside this class so we can use them in different functions. So we're going to create the instance of the motors outside of our run not mode. So we're going to say DC motor left, and we'll have DC. In fact, if we select this, it'll do the import for us, then that all works out right. Right. When our op mode starts, that's where we will tell the program where those motors are. So inside here, we need to tell it that left is hardware map dot DC motor dot get ML. If you have not yet seen the core control modules overview lesson on myroboxedu.com, I recommend going out and doing that. We have lessons that talk about how to operate the motor controller with different motor modes. So definitely check that out first, and then you'll know what these different modes are. Right is going to be hardware map dot DC motor dot get. And if you already have your motors named something, you can use your names in place of the screen text. I recommend naming it something really short. Don't put special characters in there. Don't put capitalization in there. Just have lowercase letters and a short name, because that's easy to type in on your screen. Now, right on my robot is reversed. My robot has gears on it. It has just two gears, one on the motor, one on the wheel, that are touching each other. So it might be reversed. If your robot does not have gears, then you will likely need to reverse your left motor instead of your right motor. We still have the gyro sensor. Oh, we're going to go back and do one more thing. We're going to set the mode of these motors to be run using encoders. So left set mode is going to be DC, and you can see that all these options pop up in case you forget what they're called. Run using encoders. And then we're going to do the same thing for the other motor. Right. While we're here, I'm going to set a variable, double turn speed, and I'm going to start by turning the robot at 15% power. Then we have the gyro sensor, we have the gyro sensor, we have the Z accumulated. All of that stuff has to do with the gyro sensor. Just like we moved the DC motor left and right up here, we're going to do the same thing with these two guys. So we're going to cut these from there, and we're going to actually put them outside of this function so that they can be accessed from all different functions. That's going to help us out later. Since we move these now, we're going to also just move those out right now. And then in the second part, that'll make more sense. If all that stuff is good, that's going to stay the same. Get rid of some empty space here. We're going to wait 1 second to make sure the gyroscope is not moving, make sure we're not touching the robot. Then we're going to calibrate the robot. We're going to wait for start. Then we're going to make sure it's done calibrating. Inside while op mode is activated, we're going to get the Z integrated value set to Z accumulated. And then inside here, if Z accumulated is greater than 0 and it's less than 0, we're going to do a very similar thing. So before, what we were doing was we were changing the servo position. Now, what we're going to do is we're going to turn on the robot to make it move. So we're going to say mleft dot set power to be turn speed, and mright set power negative turn speed. That way the robot is going to turn around in a circle while it's greater than 0. And then down here, if it is less than 0, we're going to turn in the opposite direction. So we're just going to swap around the negative sign there. After we set the power to the motors, we'll have to make sure that power actually gets there. So we'll have to wait 1 full hardware cycle. And then we'll want to get the new gyro reading after we wait. And then we can print that to the screen. So we've got telemetry, add data. That's good. And now we don't want to do this forever, because if you do this forever, the robot's never going to stop. At no point do we say mleft or mright set power 0. It's always setting power to something. So it's going to turn left until it passes 0, and then turn right till it passes 0, then turn left till it passes 0. And it's just going to wiggle back and forth. So we want to say that when we are at 0, or when we're really close to 0, we want the robot to stop. And we're going to do that with a while loop. So we're going to say while math.abs, this is the absolute value function, Z accumulated minus target. Don't think we made that variable. We did not make that variable. Is greater than 3. We're going to add our curly bracket here, and then we're going to finish this off here. We're going to need to make this variable target, which we forgot to make before. So I'm going to do that after Z accumulated, because it has to do with the gyro heading. And target, and initially we're going to make it 0. If Z accumulated minus target is greater than 3, or if Z accumulated minus target is less than -3. That'd be another way to put it, but this is just an easier way of figuring out, okay, if the distance between these two things is greater than 3, then we're going to keep doing this. Now once it's within 3 of our target, so between -3 and +3, then we want to turn the motors off. So we're going to take this, and we're going to copy it down here and just say motor power is 0. Now this sleep 25, remember that was for our servo, to make sure the servo can move and then we could read. We're not going to use that anymore. And even when the target is within 3 of Z accumulated, we still want to output the telemetry data. So outside of our while loop, we'll also want to put our telemetry data out there. And then we'll wait our 1 full hardware cycle, and then go back and update that value and check again, see if we are within 3 of that. So this is just going to continuously make the robot drive to 0, to the direction it's facing to start with. So download this onto your robot, try it out, change your turn speed. You can kind of see how that affects the program. You can also change this number here, 3. You can make it 6 or 10 or 15 or 0. See how that changes around the program. because this is the accuracy you need to get within. So it's going to say, well, only stop if your robot is within 3 degrees of 0. You could say stop if it's within 10 degrees of 0. 3 degrees works out pretty well for a speed of 15%. As your turn speed gets higher, you're going to need to give yourself more room for where you can stop, because as you get more momentum going faster, you're going to overshoot. When you tell the motor to stop, you're going to get on the other side of the acceptable range you can be in. Now the second thing we're going to do, and I really hope you download that to your robot, because you should definitely try that first. The second part that we're going to do is turn what we just made there into a function. So down here, this is the end of the class. We want our function to be inside of the class. And we're going to make a function where we can type something up here inside our initialization or inside the loop. We can say turn 90. And then it'll turn 90 degrees based off this, and then it'll be done, and it'll go on to the next thing. So this is going to be really great to use inside of your autonomous programs. So down here, I'm going to name my function turn absolute. We need to say this a public function. It's void. We're going to turn absolute. It's going to take in an integer. We call the integer target, just to keep with the same naming conventions from here. And this is what the function is going to do. Now, we need the function to have our turn speed. We need it to get the integrated z value. And it's going to go into the while loop, making those decisions. And really, we structured this just like that is going to be. So if we highlight everything from wait 1 full hardware cycle all the way up to z accumulated, we're going to cut that away from there because we don't need it there, and we're going to paste it down here. Now there's a couple issues that we're having. One is that z accumulated is never declared, so we'll need to say int z accumulated. We'll also need to declare our turn speed, so we can go up here and take double turn speed, and we'll move that into our function as well. So now we have double turn speed there. Wait 1 full hardware cycle. And why doesn't that work? That is because our function up here throws interrupted exception. We need to do the same thing on here. So then our wait 1 full hardware cycle works in here. So here we have our turn speed, we have our z accumulated, while absolute value of accumulated minus target is greater than 3, we're going to say, well, if accumulated is, ooh, that's interesting. So I found something we should have done in the first part, but we didn't. Before, we just had our target be 0, which is good. That works out just fine. But now our target's going to be something else. So when it was 0, this means 0 is fine. But when it's something else, we'll need to say, well, if z accumulated is greater than target, then we'll turn in this direction. If z accumulated is less than target, then we'll turn in that direction. And the way I had it in my program is actually if target is less than, yes, good. Target is greater than. Wait 1 full hardware cycle, absolute. So that right there should allow you to go up to your program, and we cut that all out, so that's good. This is a main loop. I'm gonna make sure you don't get rid of this guy. But inside of here, we could say turn absolute 90. And we could say sleep for 1 second, and then we'll turn absolute, and we'll turn to 0. And now if we said turn absolute 90 here again, it's actually not going to turn at all. It's just going to stay exactly where it is. And that's because we turn to 90 here. Well, it's already at 90. We're turning absolute. So we'll make another function that will turn in reference to where you are right now. So here, we can say we'll make another function called public void, and this one's just going to be turn. Int target, and there's our function. Now this function is going to use this function. So this one is going to say turn absolute, and the target we put in there is going to be target plus mr gyro get integrated z value. What's going funny here? Target plus mr gyro get integrated z value. Do I need to say? I do. I need to say throw interrupted exception. Oops. Totally put that in the wrong spot. That way, this program uses wait one full hardware cycle. That means this program uses it. That means this needs that as well. So now we could say turn absolute 90, turn 90, and it'll turn an additional 90, so then you turn 180 degrees. Now, the downside of this, of using this function, is that you'll accumulate this error. So when you say turn absolute 90, it may only turn to 87 degrees. So then when you turn 90, it's going to try to turn to only 177 degrees. So it's not going to be exact, and then that's all going to add up. So whenever you can, use turn absolute if you know where you're starting from. The last thing we're going to do in here is put in a interaction with your gamepad. So you can run this just as it is, and the program will go autonomously. But another thing you can do is put in interaction with the gamepad. So we could say if gamepad gamepad1 dot a, we will say target equals target plus 45. Remember that we kept our target up here, so we still have here target is 0. So it's going to start out at 0. So if we press A, then it's going to add 45 to the target. If gamepad1.b, then target equals target minus 45. Then we'll do a turn absolute with an input of target. And then we will pump out our telemetry data to make sure that that is always put out there, and we will wait one full hardware cycle. Now the Z accumulated, we actually are not getting up here, so instead we're going to say, there's no errors refreshing, so we're going to say mrgyro dot get integrated Z value, and that will go out to the telemetry data. So that's it. Now you can run this program, and when you press the A or B button, the robot is going to move either clockwise or counterclockwise, plus 45 or negative 45. Now, if this program is not working for you, be sure to make sure that you change this. My robot has gears in it, so M right is reversed. If your robot does not have gears in it, then M left will be reversed. If you have 3 gears on each side, then also M left would be reversed. If you have 4, then M right would be reversed. You got to make sure your robot is turning in the direction that your target is. If it's turning in the opposite direction, well, then it's never going to get there. But that's something you need to hard code into your program. So that's it. Now in this program, when it comes down top mode is active, it's going to check if it should change target, and then it'll turn absolute. Now in this turn absolute, it's going to update the accumulated value. It's going to create its turn speed, so you can change around that turn speed. As long as it's outside of 3 of the target, then it'll turn in the direction of that target value. If it's greater than or less than target, then it'll wait one full hardware cycle and make sure that value got to the motor. Then it'll update its new heading, or new Z accumulated, print that to the screen, and then based on the new value, it will know, okay, I'm still less than it, or I'm still greater than it, or I was less than it, now I'm greater than it. It'll make a new decision, and it'll keep going until it's within 3 of your target value. When it reaches 3 of the target value, then it'll stop both the motors, print the new, and I suppose that's kind of silly because we just do that here. So this isn't going to hurt anything, but it's a little redundant. I'm going to do that just so I feel better. Then it's going to stop the motors, and then I'll wait another hardware cycle and make sure that motor power gets to the motor, so motors actually stop. And then we'll go back to your while that motor is active and look for the next thing to do. So again, print to the screen. And if you're not doing anything else in this program, it kind of doesn't make sense to have that here either. And then we'll wait one for a hardware cycle, and then we'll go back around and see if either of these 2 buttons are pressed.